Alright, so in this video we're going to review redox reactions, so reduction and oxidation. Now, when we have a redox reaction, they have to happen, reduction and oxidation, they have to happen together. So anytime that something is being reduced, something also has to be oxidized. So it's the movement of electrons. So if you're removing electrons from something else has to be there to gain those electrons. So if we look at this reaction right here, this is going to be a redox reaction because if you look, the charges are changing. So anytime we have a situation like that, that is definitely going to be a redox reaction. So right here, I went from a +1 charge to a 0, and then here I went from a 0 to a +2 charge. So since the charges have changed, it is a redox reaction, and we will call the charges here oxidation numbers. Okay, so reduction is when a substance gains electrons. It's almost counterintuitive. Well, the reason it's called reduction, though, is because the oxidation number is reduced. So anytime that you see a reaction where electrons are a reactant, it is going to be reduced. It's gaining electrons. Now, something that we do need to cover, if a substance is reduced, it's actually something called an oxidizing agent. That's because it does the oxidizing. So it's always the opposite. So if something is reduced, it's the oxidizing agent. Oxidation would be where something loses electrons. So you'll see the electrons as a product because it's being taken off of that substance. Now the oxidation number here will increase. So with reduction, the oxidation number is reduced, and with oxidation, it is increased. So if a substance is oxidized, it's called the reducing agent because it does the reducing. So it's the opposite. So if we're looking to see whether it's a reducing or oxidizing agent, it's the opposite of whatever is being done to it. So if it's reduced, it's the oxidizing agent because it does the oxidizing. If it's oxidized, it is the reducing agent. And the way that you can remember all of this is oil rig. Oxidation is loss, reduction is gain. Okay, so if you're trying to remember whether oxidation is where you lose or reduction is where you lose, I think about oil rig. Oxidation is the loss of electrons, reduction is the gain of electrons. Alright, so you have to know, in order to figure out if something is being oxidized or reduced, you have to be able to look at the oxidation numbers and determine how they have changed. So you need to know these rules. Well, for the most part, oxidation numbers are very simple. If it's got a charge, it's equal to the charge. Now, if it's just an element, like in its pure form, it's going to have a oxidation number of 0. Oops. So let's look at this. If I have like O2, the oxidation number would be 0 here. If I had Br2, or if I had just aluminum as a solid, that would also be an oxidation number of 0. If it's got a charge on it, like if it's Cl-, it's just going to be equal to its charge. Oxygen is always -2 unless it's in a peroxide like H2O2, then it's actually -1, but usually it'll be -2. And then hydrogen, when it's with a nonmetal, is +1, which is what you see the majority of the time. But when it's with a metal, it's actually -1. Like if I had NaH, well, sodium is a +1, hydrogen is actually -1 here. It's called hydride when it's like that. And then the sum of the oxidation numbers will always be equal to 0 or whatever the charge of the compound is. So if I had a polyatomic, like let's see, permanganate, well, permanganate's charge is -1. Overall, all of these things together need to equal -1 when you add up the oxidation numbers. Okay, so let's look at an example. What we're going to do, we're going to identify what's being oxidized, reduced, and what the agents are here. Alright, so the first thing we have to do is we have to assign oxidation numbers to everything. So when we're looking at this compound, this is an ionic compound. So first of all, I know that the cation is potassium, so I know that that has a charge of +1. Then I can look at the rest of it. Well, I've got a polyatomic here, and this polyatomic has a charge of -1. So permanganate is -1. So overall, Mn and the O's have to add up to a -1 charge. Well, oxygen is normally -2, that's part of the rules, and there's 4 of those. So that's going to be a -8 so far. So I've got a -8. I need the whole thing to equal -1. So what plus -8 will give me -1? That'll be a +7. So permanganate, and the Mn, has to be +7. All right, so now let's look at HCl. Hydrogen is going to be a +1 when it's with a nonmetal, so it's +1. Chlorine is going to be a -1, so I can cancel it out and make it equal 0 altogether because there should be no charge overall. Now let's look at the MnCl2. Well, chlorine is normally -1, so normally it's going to be whatever the charge is, but there's 2 of those here, so it's -2. Well, then that means that overall MnCl2 has to be 0, so what we need a +2 to cancel out this -2. So that's going to be a +2. All right, and then Cl2, well, this is by itself, so it's just 0. Oxygen is normally -2. Hydrogen is usually +1 here. And this is just an ionic compound, so again, we're just looking at the charges, so -1 and +1. So anytime I have an ionic compound, they have to add up to 0. If it had a charge there, I would have to add it up to get to that charge. Now, when I have a compound like this, where it's got a polyatomic, I just look at the polyatomics separately to determine the charges. All right, so let's see what's changed here. Well, Mn went from a +7 to a +2, so the oxidation number is reduced. So that means that manganese was reduced, and since it is reduced, that means that it is the oxidizing agent. All right, so now let's see what's being oxidized. Okay, so chlorine also changed. It went from a -1 here to a 0 in this case. So the number went up. It went from a -1 to a 0, so the oxidation number increased here. So chlorine is oxidized, and since it is oxidized, it is the reducing agent. All right, so anytime that you are trying to determine what the oxidation number is, just remember the rules. Most of them will just end up being what the charge normally is. Now, things like manganese, things like in the transition block, a lot of those transition metals can have different charges and oxidation numbers, so you need to be careful with those. Usually, those are the things that are being either reduced or oxidized. All right, so when we have a redox reaction, we have a reduction reaction, and then we also have an oxidation reaction. So a lot of times you're going to have to divide it out and then write half reactions and then end up putting them together to get the net ionic reaction. And this is what you will do if oxygen is not involved, hydrogen is not involved. If oxygen or hydrogen are involved, then you have to go through the additional steps like we've learned previously. So let's look at 2 reactions. Okay, so you actually have 2 examples here, but I'm going to skip this one for now. So don't worry about this one. Let's just focus on this one. We're going to write the half reactions, and then we're going to write the net ionic reactions here. So if I'm looking at this one doesn't involve oxygen or hydrogen, so it's actually a little bit simpler than if oxygen or hydrogen were involved. So first thing, we're going to determine what's being oxidized and what's being reduced. Well, magnesium is 0 here. If I'm looking at this, oxygen is normally -2, and this is an anion or a polyatomic, so if I've got -2, I've got 3 of those, so that's -6, and it needs to be overall a -1 because it's nitrate, so that means that this will be +5, and silver would be +1. All right, so now let's go to this side. Well, nitrate, it's going to be the same thing here. Oxygen's -2, nitrogen will end up being +5, so you can get an overall charge of -1. And since this whole compound needs to be 0, you've got -1 because each nitrate is -1. There's 2 of those, so that's -2. So to cancel that out, we're going to put a +2 here. And then silver's by itself, so it's 0. So magnesium went from a 0 to a +2. So we're just going to concentrate on what is actually being oxidized and reduced here. So, like this. I'm not going to include the nitrate here because nothing is happening to its charge. It's going to end up having the same charge. So if you have a single replacement reaction, the anion will end up disappearing in the net ionic and the half reactions because nothing's actually happening to it. It's a spectator. All right, so I need to fix the charges here. So I'm going to add electrons to the more positive side so that they are equal. So I've got a +2, I need to get rid of that, so I'm going to add 2 electrons. +2 and a -2, that equals 0, which is what we have on the other side. Okay, and then this, since the oxidation number went up, that is being oxidized. So that's my first half reaction. Now let's look at silver. Silver went from a +1 to a 0. So that means we have a +1 side on this one, and then it's going to go to a silver or 0 charge here. And technically, you really need to include the states of matter and net ionic and these half reactions here. Okay, so we've got a +1, 0 charge in this, so we need to add electrons to the more negative side or more positive side. So this is a +1. I'm going to add 1 electron to cancel that out. +1, -1 equals 0. Got 0 on the other side. Okay, so now we'll just put them together. But if we're going to do that, we're going to cancel out the electrons because electrons are not included in the net ionic reactions. So I've got 2 electrons for this one and only 1 for this. So I need to multiply everything by 2. So it's going to be 2Ag positive plus 2 electrons produces 2 silvers. All right, so now I put everything together. Electrons should cancel at the end because I've got electrons on my product side here and then on my reactant side there. So that will cancel. And this is what I will get when I put everything together. Plus 2Ag positive produces Mg with a +2 and then 2 Ag solids. And if you look at the equation, it's still balanced. You've got 2 silvers on both sides, 1 magnesium, and then also the charges should be balanced. So 2 times the +1 here gives me +2, 0. And then I've got a +2 here, so everything should be balanced, the charges and the atoms. All right, so now what do we do if we have oxygen and hydrogen? So you should remember this from earlier this year, but I'm going to review it because I know it's been a while. So the first thing you do, break it into 2 half reactions. Then you're going to balance everything but the H and O. So make sure the number of atoms are equal except for hydrogen and oxygen. Then you're going to balance the O's by adding water. Then you're going to balance the H's by adding H pluses, assuming it's acidic solution. If it's acidic, it'll usually say in acidic conditions. You're going to add electrons as you needed to. And then multiply each half reaction by some number so the electrons cancel. And then add the 2 half reactions and simplify it. Now, last step is only for a basic solution. If you have a basic solution, you have to do this additional step and get rid of the hydrogen ions, because if it's in a basic solution, you shouldn't have more hydrogen ions than hydroxide. You should have more hydroxides. So you're going to add hydroxide to cancel out the H pluses. You're going to get water, and then simplify it again. All right, so let's look at an example. Okay, so we have dichlorine. Assume we have acidic solutions here. We're going to assume that we have acidic conditions. All right, so first thing, let's divide it out into two half reactions. So let's look at the chromium first. All right, so oxygen is -2. Now I've got 7 of those, so that's going to be -14. Overall, this whole thing has to equal a -2. So -14. What plus -14 will give me a -2? We'll get that will be a +12. So I've got 2 of them here though. So since I've got 2 of them, then each of them has to be a +6. All right, so chlorine is just a -1. Then right here, chromium is just going to be a +3, and then chlorine gas will be 0. All right, so we've got a reaction here to here. So it went from a +6 to a +3. So that means that this is being reduced. So that's one of our reactions. And then we go from a -1 to a 0, so it's being oxidized here. So let's go ahead and divide those two things out. So I have one reaction happening here. It's being reduced. And then my other reaction is going to be this, where it's being oxidized. So I have my 2 reactions right here. So we're going to focus on each reaction, just focus on one thing at a time right now. All right, so let's look at this one. So if I look at the number of atoms, that's not balanced. So I need to fix that first. So I have 2 chlorines, 1 chlorine on this side, so I'm going to make it 2 on this side. So now I've got the same number of atoms, but I need to look at my charges. I don't have to worry about hydrogen or oxygen here because that's not involved. So I have got -2 on this side and a 0 on this side. So I'm going to add electrons to the more positive side, so this side, to make it equal the other side. So I've got a -2 on this side. I'm going to add 2 electrons to this side. That's going to give me a -2 on this side, -2 on this side. All right, so now I can leave this one alone until the end. So let's look at this one. I have Cr2 and Cr. So I need to fix the number of atoms first. Be really careful when you have charges like this. Make sure you drag it down each time. Otherwise, you have a good chance of getting it wrong because you forgot to add a charge somewhere. All right, so now I've got 2 chromiums on this side, but in this situation I have oxygen on one side and no oxygen on the other side. So what I need to do is I need to fix that by adding water. So I need 7 oxygens on this side, so I'm going to have 7 water molecules. Well, now I've got hydrogen on one side and I don't have it on the other side, so I'm going to go and add hydrogen ions to fix that. So I've got 7 times 2, that's 14. So I'm going to need to add 14 hydrogen ions to this side. All right, so now I've got hydrogens balanced, oxygens balanced. Now I need to add electrons so I can get the charges to balance. Okay, so I've got a +6 on the side, and this will be 0. I'm not looking at oxidation numbers here, I am just looking at charges overall, okay? So I have a -2, and then I have +14 here. So +14 plus a -2 will give me a +12. Well, I'm going to add electrons to the more positive side so that they are both equal. So I'm going to add electrons to the reactant side. So 14 hydrogen ions, one of these. Okay, so I need it to be this +12, I need it to go down to 6. So I'm going to add a -6, and that'll give me a +6. So then I'll have the same number on both sides. So Positive 14 plus negative 2 plus a negative 6 will give me a positive 6, which is what I have on the other side. All right, so now I've got that fixed. So I'm going to put these two equations together, but I need to get the electrons to cancel. So I've got 6 on this side and only 2 on this side. So now I'm going to multiply this reaction by 3 so that I can get 6 electrons and they will cancel. So multiply everything here by 3. So I'm going to get 6 Cl minuses, don't forget your charges, 3 Cl2s, and 6 electrons. Okay, so now we're going to put everything together, and then hopefully at the end the charges should be equal and we're good to go. All right, so now I'm going to put my reactants together. So 6 Cl minus plus 14 of this plus Cr2O7, and of course if anything else canceled you would take that out as well. My electrons will cancel. So now let's look at our product side. I've got 3 of these, 2 of those. So I'm just putting everything together, and then 7 waters. All right, so now let's just check, make sure our charges are equal on both sides. So we have a negative 6, positive 14, and a negative 2. And then on this side, I have a 0, I have a positive 6, and then I have a 0. So when I add these together, I should get positive 6. So everything is equal. So this is my complete balanced redox reaction right here. So it's just tedious, so just make sure you are very careful about when you pull things down and you change things.